Okay, so today we are going to be talking about the properties of rectangles. Properties of rectangles. All four angles are right angles. Opposite sides are parallel and congruent. Opposite angles are congruent. Consecutive angles are supplementary. And diagonals bisect each other. All right, so 5 properties of rectangles. All 4 angles are right angles. Opposite sides are parallel and congruent. Opposite angles are congruent. Consecutive angles are supplementary. And diagonals bisect each other. So let's look at that real world example on the bottom of page 423. And we're going to apply this rule, or apply these rules, to find segment lengths and angle measures inside of a rectangle. So if we've got this rectangle, PQRST, we're told PS is 180. PR is 200. Find QT. All right, so Q to T is right here. Q to T. Now, you're told that P to R is 200. So P to R is a diagonal, and it's 200. So If we take this 200 and we divide it by 2, it would give us the length of half of a diagonal. Agreed? PR divided by 2 would give us T to R, because T is the midpoint of this diagonal. Well, once we find out one of the lengths of these diagonals, or one of the lengths of half of a diagonal, all of these halves of diagonals are congruent. So if we need Q to T, we're going to take 200 and we're going to divide it by 2, and we get 100, right? Well, T to R is 100, but T to R is equal to QT, so QT is 100 as well. It's just half the length of the complete diagonal. We got a question there. If TS equals 120, T to S equals 120, find PR. So T to S, again, right here, from T to S, they're telling us that that's 120. And we need P to R. So if T to S is 120, then T to Q is also 120, right? If this is 120, this piece is 120. And aren't they all 120? So if all of those half pieces of diagonals are 120, then P to R is equal to 120 times 2, which is 240. You're told the measure of PRS, measure of angle PRS, is equal to 64. Find the measure of SRQ. All right, so PRS, this angle right here. Starting at P, down to R, and over to S. That angle is 64 degrees. We need to find the measure of angle SRQ. So SR up to Q. So we need this angle in here. In our rule, said that all 4 angles are right angles. So this angle here is a right angle. And if the blue portion of it is 64, then wouldn't the yellow portion be 90 minus 64? So if we need the measure of SRQ, that's going to be equal to 90 minus 64. And 90 minus 64, 26 degrees. All right, the 2 angles in each vertex sum 90 degrees. Both of the angles, or the sum of the 2 angles in each vertex, is 90 degrees. Okay? So look at example 2 on the top of the next page. This time our rectangle is JKLM. The midpoint of our diagonals, that's point P. If the measure of JKL, all right, this whole corner, the measure of angle JKL is equal to 2x plus 4. And the measure of JLK is equal to 7x plus 5. Find x. All right, so this angle, JKL, starts at J, goes to K, and then back down to L. Well, it's one of the angles in the rectangle. And all of the angles in a rectangle are 90 degrees. So this 2x plus 4 is equal to 90 degrees. So we can subtract 4 from each side. Our 2x is equal to 86. And then divide both sides by 2. And we get an x that's equal to 43. So there's our value of x. If we needed to find the measure of JLK for some reason, all right, we could substitute it. So we could take 7 times 43 plus 5. JLK. Yeah, I don't think we're going to do that example because that's not going to give us very, very accurate data. Okay. So the 4 angles in a rectangle are all right angles. They're all 90-degree angles. We got a question that says if JP is equal to 3y minus 5 and MN is equal to 5y plus 1. Find y. So J to P, from J to P is 3y minus 5. And from M to K, this shouldn't be an N right here. This should be a K. Sorry about that. All right, J to P is 3y minus 5. And this whole diagonal, M to K, is 5y plus 1. So what we've got is a whole diagonal, and then we've got half of a diagonal. All right? So this piece right here, J to P, if we multiplied it by 2, it would give us J to L. Agreed? J to P times 2 would give us j to L, the entire diagonal. And the diagonals are congruent to each other. So the equation that we can write, we can say that 3y, or 2 times 3y minus 5, all right, 2 of these pieces right here, basically this piece times 2, which would be 3y minus 5 times 3y minus 5, is equal to this entire diagonal, m to k. So there's our equation, equals 5y plus 1. So we got to do the distributive property here. We got 6y minus 10 equal to 5y plus 1. Subtract 5y from each side. So y minus 10 is equal to 1. And then add 10 to each side. So we get a y that's equal to 11. So those are a few examples of the types of problems you're going to have today and how you can use the rules related to rectangles to solve these quadrilateral problems. All right, your practice for today. Will be on page 426. Problems 10 through 19. Since we're on a short week, we're going to do 8 ALEKS topics this week. All right, 8 ALEKS topics will constitute 100% quiz score. So there's your practice, and please get started on your ALEKS topics sooner than later.